This is the independent activity number sense. Question 1. Which of the following does not represent the set of counting numbers? What are the set of counting numbers? Numbers you can count on your hands. Okay. So we have n here, which is a set of natural numbers, which is a set of counting numbers. And this other one here, we have 1, 2, 3, 4, 5. They're also part of the set of counting numbers. And then we have positive integers here. That's also part of the set of counting numbers. The only one that it's not is this one here marked in red, 0, 1, 2, 3, because you cannot count 0 on your hands. So that's the correct answer for number 1. Number 2, which are given in the set of natural numbers. Here again, the same thing as a set of counting numbers. So 31, which are included, 31, 10, and 1970. They're all part of counting numbers. -12, 0, square root of 5, fractions. They're not part of the set of natural numbers. Part B, what are the set of rational numbers? What are rational numbers? Rational numbers are numbers that can be written as a fraction. Okay, so here we have 8, as 8 over 1, 15, -15, we're written as -15 over 1. That's a fraction already. 0 can be 0 over 1. You can have 857 over 1 as a fraction. And this can be 9 5/10. That's a fraction. Or as an improper fraction, you can write it. And here we have 3/8, and that's already a fraction. A set of irrational numbers. Now, what are they? So rational numbers are numbers that can be written as a fraction. Irrational numbers are numbers that cannot be written as a fraction. So there's two numbers here. Pi, which goes on forever, so it can't be written as the ratio of two integers or two numbers, and the square root of 2, which cannot be written as a fraction. Question 3. Remember, irrational numbers cannot be written as a fraction. So the numbers like square root of 2, pi, negative square root of 5, etc. Rational numbers are numbers that can be written as a fraction. They're numbers like 2, -3, square root of 9, which is 3, 1/2, negative, and repeating fraction here, 0.78. So then it asks us to complete the following. An irrational plus a rational number is going to be an irrational number. For example, 0 plus pi is still an irrational number. In part B, an irrational number minus a rational number, okay, is still going to be an irrational number. So if you have pi minus 1, it's still going to be an irrational number. C, an irrational number times a non-zero rational number is going to be an irrational number. Okay, and part D, an irrational number plus an irrational number. It could either be a rational or irrational number. Okay, part E, an irrational number times the irrational number. It could be either rational or irrational number. Okay. Part F, the quotient of two irrational numbers. Okay. Could be either rational or irrational. He doesn't say the same irrational numbers. He says the quotient of two irrational numbers. They may be different. And that was question 3. Question 4. Choose the correct answer. An irrational number plus a rational number is an irrational number. An irrational number minus a rational number is minus a rational number is going to be an irrational number. So if I have pi minus 3.14 minus 1 is still going to be an irrational number. Okay. And it looks like it's the same problem. Let's go on to question 5. Please list of numbers determine which are included in the set of natural numbers. The set of natural numbers here. Let's see if that's the same as 2. Okay. Okay. Set of natural numbers. Remember, natural numbers are the numbers that occur in nature. 1970, 31, and 10. They occur naturally in nature. You wouldn't find a negative 12 appearing. You don't see 4/5 appearing or square root of 5. The ones that occur naturally in nature. Okay. Well, counting numbers, I should say. Part B, the set of rationals. Numbers can be written as a fraction. So you have 9/5, negative 15, 8, and 0. All these can be written as a fraction. They're all rational numbers. Okay. 3/8 is a fraction. 857 over 1 would be a fraction. And the one there is not a square root of 3, which can't be written as a fraction. It's irrational. In this case here, the set of irrational numbers, only 2, square root of 2 and pi. Now, percents are simply fractions with a denominator of 100. So 7% is another way to write 7 over 100. A TV set was originally priced at $1,500 last week. It went on a 7% off sale. That means the price of the TV was reduced by 7%. So what's the new price going to be? Okay. So I have the new price is going to be the old price times whatever decimal percent that happened to be. So 100% would just be 1.0, but it's going to be taken off a little bit. So I subtracted the decimal form of 7%, which is going to be 0.07. So I have 1 minus that. So it's going to be 93% of its original value. And you multiply it out, you end up with $1,395. There's a video for that one too. That was number 6. Number 7. How do you classify number 57? Can it be written as a fraction? Yes. Is it a whole number? Yes. Is it a natural number? Yes. Is it an integer? Yes. Okay. Number 8. Classify this rational number here. Okay. Is it an integer? No, it's not. Is it a whole number? It's a fraction. No, it's not. Is it a natural number? No, it's not. It's a rational number. That's the only one applies. It'll probably be written as a fraction. Number 9, classify the number here. Is it an integer? No, it's not. Is it a natural number? No, it's not. Is it a whole number? No, it's not. It's a rational number. It can be written as a fraction. Number 10, select all. This says apply this number belong 1. It's a natural number. It's a whole number. It is an integer. Written as a fraction? Yes, it can. Is it a real number? Yes, it is. So those are all that apply. Okay. Number 11, 22 belongs to which one of these? Is it a natural number? Yes. Is it a whole number? Yes. Is it an integer? Yes. Can it be written as a fraction? Is it a rational number? Yes. Is it a real number? Yes, it is. So here we have the set to which all this number belongs. So is it a natural number? No, it's not. Is it a whole number? No, it's not. Is it an integer? Is it an integer? No, it's not. Is it a rational number? Yes, it is. It can be written as a fraction. Is it a real number? Yes, it is. It is a real number. Number 13, this number here, 9.72 repeating. Can be written as a fraction. It's a fraction, and it is a real number. So which does this belong to? 3/2. It is a fraction, a rational number, and it is a real number. Okay. 15, 3/7. That's going to be a rational number, and it is a real number. It's not natural. It's not a whole. It's not an integer. It can be written as a fraction, so it's a rational number, and it is a real number. Okay. Go to 24. Is it a natural number? No, it's not. It doesn't occur naturally. Or it's not a counting number. Whole number. Square root of 24? No, it's not. Is it an integer? No, it's not. Is it a rational number? Can it be written as a fraction? No, it's not. It is an irrational number, and it is a real number. Select all the sets to which the following apply. So this similar one here. It's not natural. It's not whole. It's not an integer. It's not a rational number. It can't be written as a fraction. It is an irrational number, and it is real. -5. Is that a natural number? No, it's not. Is it a whole number? No, it's not. It is an integer. -5 is an integer, and it is a real number. Number 19. -5. Is that a natural number? No, it's not. Is it a whole number? No, it's not. It is an integer, and it can be written as a fraction, and it is a real number. Number 20, pi. Is it a natural number? It's not a natural number. Is it a whole number? It's not. Is it an integer? Not an integer. Is it a rational number? Can it be written as a fraction? No, it can't be. It is an irrational number, and it is real. You can divide real numbers into the set of numbers that can be written as fractions and numbers that can't be written as fractions. That's what the set of real numbers is going to be. The set of numbers that can be written as a fraction and the set of numbers that cannot be written as a fraction. Okay. In this case here, pi, we just did that one. And we just did that one. Here we have 3 with repeating. It can be written as a fraction. It's like 1/3. It's repeating. And it is real. 42, that's a natural number that occurs in nature. Whole number. It's an integer. It can be written as a fraction, and it is a real number. Remember, we said real numbers are the set of numbers that can be written as a fraction and the numbers that cannot be written as a fraction. that they compose a set of real numbers. In this one here, you have the square root of 21. It's going to be an irrational number because it can't be written as a fraction. And it is a real number. 27, number 26 here. 14, it's not a natural number, doesn't occur in nature. It's not a whole number. Whole numbers are zero, the set of zero in the set of natural numbers, so it's not a whole number. It's not an integer. Well, is it an integer? Yes, it is. It's an integer, and it can be written as a fraction, and it is a real number. Number 27. So 2/5, that's a fraction, and it's a real number. It's not an integer, it's not a whole, and it's not a natural number. Okay, and that is the end of independent activity for number sense.